Hey, good evening, everyone. Welcome to today's class. Hope everyone is doing good. All right, so let's begin the session for the day. We're talking about classes and objects today. What is this terminology, which looks very familiar, right? Classes and objects. So if I have to speak about Python's capability, Python is capable of many things. For example, if I go to the 360-digit-mg website, and then here there is mind map. If I click on that, I get these multiple mind maps. I'll go to Python programming fundamentals. I'll click on this and I open this mind map for Python. Under the features, we can see that Python has many features which are listed down here. And specifically, if you focus here, it's dynamic programming, very good. But it also has object-oriented programming, functional-oriented programming, shell scripting capabilities, and modular programming capabilities. So these are multiple things which Python is capable of. Now, what does object-oriented programming language means? In short, this is called as OOPS. Object-oriented programming. In all our academics, at least in my time when we were studying, we were taught only object-oriented programming capabilities in our academic time. But times have changed, right? For you people, in today's world, we are talking about functional-oriented programming, right? It's Python everywhere. And in Python, we are specifically looking at functional-oriented programming. So what exactly is object-oriented, right? I tend to explain this at a very, very simple terms. I basically try to give a English kind of a definition. Now, before we proceed to understand object-oriented programming and the difference of this object-oriented programming structure or approach to functional-oriented programming approach, we need to first understand certain terminologies in the default programming paradigm. So when we speak about the object-oriented programming language, it uses something called as objects, and we also have something called as classes. Right? The concept uses objects and classes for doing the programming. We will try to understand what does these definitions, right? What does objects means? What does right, a class means? Class can be defined as a collection of objects, right? It at a very simple term, you can basically talk about a class as collection of objects. You can also say class is kind of a user-defined framework or code or logic, which basically is applied on the object to define its characteristics, right? So in simple terms, let me put it. Object basically means data, okay? Object is nothing but data. In programming languages, different people come up with different explanations, different definitions. But for us, let us keep things simple. We will understand that object is like a data. Okay, it's nothing but data point. Now, for every data that we look at, there will be certain characteristics, right? These characteristics will help us to understand the data into real world scenario, right? We are trying to map it to real world scenario. This definition is called as class. You can imagine class is like a definition to your data, which defines your data. That's basically a high level definition of your class and objects. If I have to put it even in simpler terms, class is like a code which is applied on data, right? Now, what is functional oriented programming language? Again, in functional oriented programming language, we will look at a terminology called function. Here we are looking into the terminology called object, and the characteristics of the object, we will basically have classes. Okay. Now, if I talk about function is like a logic that we are defining, or an application or code that we are writing. Yeah, logic, or you can say it is the lines of code that we are writing is a function. Now, as the terminology says, it is object-oriented programming. That means the programming that you are writing, the program that you are developing, you would focus around the object that you are dealing with. So the entire logic or the code that you are going to design or write or develop will revolve around this object only. Right? Whereas functional oriented means the logic is implemented. When you're developing a program, you're basically trying to apply the logic or develop the logic, irrespective of what data you're going to basically look at. Right? So that's object oriented and functional oriented concept. I'll put a very simple example here. If I have some data, X, 1, 2, 3, 4, 5. Standard data we are taking, standard example. Now, if I have to deal with this particular data in OOPS concepts, in object-oriented concepts, we will have to first define or declare. You have to declare the variable, then define the characteristics of the variable. Declare and define. Define is nothing but we are saying that it is basically going to store integer values. It's pointing to integer values. And then we assign the values to a variable. Typically, these are the 3 steps that we take in object-oriented steps. And then, because your data is defined already, it says it is integer, we will be able to write certain logic on integers only. So the logic that you want to write, whatever the logic is, it would revolve around the same data only. If I will change the logic to, let's say x2 is 1.1, 2.5, 3.3, right? 4.2, 5.6. If we have this kind of, or 5.7, if you have this kind of data, right? Then the same code that we have developed here will not be applicable for this data. Right? So this is a challenge with respect to your object-oriented programming, because your entire code is revolving around the objects, that is your data. Right? So this is the challenge that we will have. Whereas if I have to talk about functional oriented programming language, whatever is the logic that you want to develop, you will be developing that in code. Logic or code will be developed. You're writing this. So irrespective of what data we want to apply, the code is developed first. The logic is written first. Then we pass data to this. Right? And of course, the system has to understand whether the data is numeric or non-numeric based on what you are trying to develop here. Irrespective of whether it is integer or float, if the code has to work on numeric data, then it will work. You can pass X, you can pass Y, you can pass Z, you can pass A. These could be any variables which are numeric. If this code is numeric concepts that we are developing, it can be either integer or float. You don't have to change the code. The function can be used as is on this particular data. Right? So this is your difference between object-oriented and functional-oriented programming interfaces. Object-oriented programming, right, is basically good for people who are actually core developers, who understand the entire system, who understand the data, who understand the basically the entire paradigm. Because programmers will have more control while they develop the object-oriented programming. Right? Whereas if we talk about functional-oriented programming, functional-oriented programming is already written for us. Right? Somebody has written the function. We will be simply taking the function and trying to reapply that function on a different data. So that's one of the primary differences that we have. And from the coding length perspective, object-oriented coding obviously will take a lot of time. Whereas your functional programming, right, is basically whatever this is the code. For better management, we are splitting that code into sub-functions, subcodes. Right? So it basically allows us to manage the code better in functional-oriented programming languages. Now, an object, if you basically have to understand the object and classes, let us go here. As I mentioned, object can be treated as data, right? And it is basically pointing to a, generally from a definition perspective, object points to a real world entities, right? And all these years, OOPS concepts were used. Later on, right, we have functional oriented capabilities taken over. But yeah, the base is always base, remember that. Now, let us try and look into the Python's capability with respect to the OOPS concepts. Whenever we talk about OOPS, there are certain concepts, principles that we need to look at. From a definition perspective, we talked about classes and objects. We also have something called as method, right? This is nothing but a logic, or you can say a function. Then from features perspective or capabilities perspective, we have very popular inheritance capability, right? Inheritance capability. Then we also have something called as polymorphism, poly, right? And morph, polymorphism. Then we also have something called as encapsulation, then abstraction, data abstraction. So all these are different features that your OOPS concepts give. We are going to talk about inheritance and polymorphism today, along with trying to understand classes, objects, and methods. So this is an object. Example, we are trying to create here an object. So let me execute this. I'm simply saying x is equals to 10. Right? I'm simply saying x is equals to 10. So we are basically defining x and right, storing a value 10, which is referring to that particular X. So that's basically your object, right? Very simple. As I mentioned, it is nothing but data. We can try and basically refer to that X variable to get the data as well. So object is a real world entity, right? It basically has some magnitude, some from a logical standpoint, we say that it has some state and it also has some characteristics or behavior, we basically call it as. In Python, right, everything that we deal with is considered to be an object only, right? And all these objects will have attributes and something called as methods, right? So let us try and look into something called as a class. As I mentioned, class is nothing but a collection of objects. It logically explains the entities using the capabilities, or sorry, using the attributes or definitions and methods, right? So if you basically talk about employee data set, right? If I talk about employee data set for any organization, right? There is this employee database. In the employee database, each employee is basically a class, right? It's basically employee class. Now this employee, each employee will contain the attributes and methods. Attributes are nothing but like the characteristics, like employee ID, right? Name, age, gender, designation, the columns that we are talking about, right? Those are called as attributes, right? So that's basically how your class can be defined. So here we are trying to talk about this class. We are looking at this class bike, right? We are trying to basically define this class. This is the name. And within the class, we will have attributes and methods, right? Now, what is a method? Method is nothing but a function. You can imagine method as a function. Function is nothing but some lines of code, which when executed gives a specific result, right? So that's about your method. So let us try and understand this. So we have this class bike, and for that we are defining the methods here, right? We are trying to define certain methods. Now, the function that you're seeing here, right? We're basically defining a function here under double underscore init and double underscore. Now, this is always the first method or first function, you can say, and it is very special for your object, for your classes in Python. This is called as a constructor. This function is called as a constructor. This will initialize, right, the code or the instance of the class. So when you're trying to create a new class, then this method will first, execute. So this is about your initialization method, or it is also called as constructor. And you can see all the other functions, all the other methods are just like your functions, regular functions, right? The first argument, or the only argument that I have here, is self. So in Python, we add this self argument to the function, right? It is by default, Python adds self function. So when you're trying to call the function, you don't need to add it, but by default, Python will have it, right? Now, I'm defining the initialization function or constructor here. My screen size is 150, 175. Even this is not visible, then I think you need to probably watch the session in your mobile, in your laptop, not in mobile. So try to access the session from system, not from a small screen. Yeah, so let us try and do this. All right, so class bike, and then we are initializing or we are defining the constructor. The first argument is always self, and we are passing this bunch of other arguments, and we are defining the right mapping basically. This is constructor. Next, for each of these functions, right, we are basically defining each of these methods here. We are writing some code. We are basically saying read the data here. If you get that, then print it. Here we are basically printing the area. Here we are writing some configuration, and this is speed. We are defining the speed, right? 250 kilometers per second. So this is basically the methods or functions that we are defining in your class. Now you will have multiple objects in this class. Okay, next. We are creating these instance objects, okay? And in it is basically the constructor which initializes the class. Let us execute this. Yeah, we are executing this. So now my class bike is defined. Next, we are basically trying to pass the values and initialize the constructor here. I mean, this is like calling a function. We are defining on creating the class here, and here we are calling that particular class, right? So when you pass these arguments like this, we are going to this particular class, first argument, right? And this init is a initializer, or you can also call it as initialization method or constructor. So this is basically triggering the function, right? Now this is like your initializer or constructor. And from this comp1, which is basically the entire code, we are calling config. This particular function is what we are calling. When you do that, it prints this simple result, right? It's printing this. If I say get underscore mpg, within this class function, I'm referring to this function, right? Class bike. Within that, we have get mileage function or method. So I'm trying to reuse these same terminologies again and again, and that too with trying to compare it with the terminologies of object-oriented and function-oriented. So this is a function or method. Both mean same. Method means in your object-oriented. Function basically means your function-oriented program. So here we are executing comp1.getMPG. So it is referring to getMPG. It prints self.mpg, whatever is the value here that we pass, 55. That 55 will get printed here. Yeah, look at this. Okay, so this is basically your very simple example of class. There are a bunch of inbuilt class attributes that we will be trying to look at. One of the inbuilt attribute, the first inbuilt attribute is double underscore init, init and double underscore, this one. This is called as constructor. Similarly, we will have many other readily available inbuilt attributes. Like we also have something called as double underscore doc, double underscore, right? So this is a documentation class. Then we'll also have something called as underscore underscore name, right? This is basically the name of the class. So these are some of the default attributes which we have in OOPS concepts. All right. Next, we also have something called as inheritance. Now, what does this inheritance mean? This is very, very important feature for your object-oriented approach, programming approach. So what is inheritance? Now, I'll put this, again, very simple terminologies. Let's say you are XYZ. This is you. Okay. We generally say, I mean, even in movies, we see that, right? Suddenly you are left out with a lot of, assume money, right? From your family members, right? You're probably forefathers or your father might have left you some money. So you inherit the property. We generally use that terminology, right? We inherit the property. So it's like, let's say this is your grandfather, right? Grandparents. They left some money, they left some property or some features or something. This will automatically be inherited by parents. From your parents, you will get all those properties here to you. So inheritance means passing the characteristics of the parent objects to child objects, right? So that's very simple terms. The inheritance means characteristics or properties of parent class objects will be passed on to child object classes. Child objects. This also allows us to kind of reuse the code, right? So we can create a class and then inherit the entire properties of parent class into this, right? So we'll see some definitions here, some code examples here to make life easy. Now, when we talk about inheritance, there are certain terminologies, as I said. We will basically call this as parent object. The first one is parent object. This is like your higher level class. From this parent object, we will be passing on the characteristics to child object. I'm basically explaining the topic, titles. Okay, parent object to child object. So the properties and or behavior or the characteristics of this object will be inherited to child objects. When you're trying to create objects, right? If you try to use these inheritance properties and then pass on the characteristics to your new class objects, then those new class objects are called as child class, right? It's called as child class, right? And from where we are getting this? Base class. This is nothing but parent object. Now we will have different types of inheritance also. You'll have single level inheritance. That means from parent to child. Multi-level, just like how I have shown, we have maybe grandparents, and then from there to parents, and from there to child. This is multi-level. Then we have multiple inheritances. For example, maternal, right? Both from, let's say, your only kid, and you're basically getting the property from mother's side as well as from the father's side, right? So we are basically talking about parent class, mother's class, father's class. From both, you might take the characteristics, right? So this is basically your multiple inheritances. So this way we have multiple right, inheritance characteristics that we can look into. For defining this, let's look at a small example. A normal class definition. This is a very simple class that we are defining here. I'm saying class A, and this is the methods that we are defining here. Product 1, print name product 1. You're just printing it, whatever the value that you're passing. Then similar to product 1, we also have product 2, which is very simple, similar. It's just the name changes. We are using the constructor or initializing the code. And then here, we are printing the results. So I'll define this. Okay, I'm executing this. So here, I'm basically calling this product 1, right? So it is printing this. ID for name underscore A. This is the constructor or your class initializer. It has a unique ID in the backend. So we are trying to print that unique ID as well. So these are the two outputs that we see. Now, we are trying to put this class here, class B of A. Class B of A. I'm calling product 3 products. Initializing the class B, and I'm printing ID for class B. Right? So I'm basically initializing this. And then we are also trying to print this product 3. So this is a different number. This is a different number. Right? And when I say name of B, it gives us that, and name of B product 3, then this is the code it is printing. Right? There's nothing complex or serious here. It is just a simple class that we are defining. Right? But I'm using name of B, this name underscore B, and then I'm trying to refer product 1 or product 2. I can always do that. Because here we are calling this superclass for your subclass. So all the characteristics or all the methods that are defined in class A can automatically be used in class B. Yeah, that is the inheritance properties. So here we will be using product 1. Product 1 is not there here. We have product 3 and product 2. Product 1 is here. Right? So here we'll print that. When I say product 1, oh, sorry, I have not defined this, my bad. Let me execute this. Yeah, so you can see I get a different number from here to here. There's completely different number. And when I execute this, because we have inherited the properties here, characteristics of class A, which is this part, is also identified for class B. We can also define class C. And I'm initializing class C also here. So we have class A, class B, and class C. This is a simple inheritance. single level inheritance. Here we are doing multiple inheritances. So I'm defining class D, which takes the characteristics from class A and class C also. In class D, we have product 7 and product 8, whereas class C, we have product 5, product 6. When I initialize this class D, right, it automatically refers to this class also, right? Class C and class A. All those characteristics are automatically retrieved or executed. Now I will say name underscore D and product 1. Product 1 is not there. Product 1 is under the class A. So it automatically reads that and prints the result as this product name 1. We are printing the product name 1. Now this, you can see, is basically allowing us to reuse the existing code, right? So this is the benefit of inheritance, where we can pass on the capabilities of one class to another class, right? We can inherit the properties of other classes. Then after inheritance, we have another very important feature, which is called as polymorphism. Polymorphism. So we will split this into two parts. We have poly and morph. What does poly means? Very good. Yes. Yeah. What does poly means? Poly means many. Simple English definition is many. Morph means, again, English definition, it is nothing but a shape or the construct, right? In simple terms, it's a shape that we are talking about. So we are basically saying that we will have many shapes, right? That means we will basically have the flexibility to achieve a task in different ways, right? So this is polymorphism feature. So polymorphism generates, basically means that it allows us to, right, get different results for the same function, right? So I have one function, but I can get different answers, different results when I'm executing that particular function. That's polymorphism capability in Python. So let us try and execute polymorphism codes also, polymorphism as well. So here I have class of bird, right? And in this bird class, we have two methods, intro and flight. Introduction. Intro means introduction to a species called bird. We're saying that there are many types of birds. Then flight. This method basically defines that most of the birds can fly, but some cannot, like ostrich, they cannot fly. So we are defining some characteristics here, right? Using methods. Next, this is one function, friends. This is one class, right? Bird class. We also have another method or another class that we are defining here, which is called as a sparrow. And here we are doing inheritance as well. I'm doing inheritance. So bird is a super class, or you can say parent class. and Sparrow is the child class. So here I'm writing flight. Now this is also flight. This is also flight. Sparrows can fly, whereas ostrich, flight function says ostriches cannot fly. Right? So this way we have different classes with a different code. So flight is the same function, but you can see there are three different answers to that particular function. Right? Polymorphism. Same function, different results. Here we are initializing, right? We are basically constructing the object, class object. So I'm defining bird, sparrow, and ostrich. So we have these classes created, and then we are calling the flight function here, right? But there are three different flight functions. Which one should I call? I'm saying object dot underscore bird. This is from the first class bird. So when I say object underscore bird, which is right the bird class, and if I call this function, it will print the function which is defined here. Most of the birds can fly, but some cannot. But if I call the same function, but from this different class, sparrow class, then it should return sparrows can fly result. Similarly, when I'm calling the function for ostrich, we are saying ostriches cannot fly. Right? So this way, we basically can again have reuse feature where we define the code, we define the classes. The same function or same method can have different meanings. And based on the classes, these meanings will change. Right? Now, this is also something which is very, very interesting to understand from Python perspective when you are trying to demystify the concept of packages. In Python, we are trying to use functional oriented capabilities, not this object oriented capabilities. So packages are nothing but, I can say, a folder. Right? It is like your, you can say, class. Within the packages, we will have folders or files. If you're referring to any specific submodule or class, then we use the hierarchy using this dot symbol in Python. Right? So that is basically to have this syntax satisfied. So object name, then you're talking about the method. Right. So this is about, at a high level, object-oriented capabilities. We also have something called as encapsulation. Right? It's basically talking about capsulating, right? That means restricting access to the variables, or you can talk about methods. So the data and the code both will be wrapped together as a single unit in OOPS concepts. That's called as encapsulation. Encapsulation or encapsulation. Combining, capsulating. Right? This is also called as data abstraction in other terminologies. So we basically are looking at the high-level difference between OOPS concepts and functional-oriented programming language concepts. In OOPS, as we discussed, the focus is on objects and then classes. And we also have methods which are basically applied onto your class using the objects. Whereas in functional oriented language, we basically only focus on functions. right? Which is nothing but methods. So that's first level difference between OOPS and function oriented capabilities. And in Python, all the OOPS concepts are also understood by Python, like we have discussed inheritance and polymorphism concept. So this is about your OOPS concepts. Now, as we discuss, there are a lot of things that come into the picture, especially when we talk about OOPS, the terminologies and all that. So try to remember all these different terminologies, starting with class. We discussed about object. We discussed about method, right? Then we also have something called as inheritance. Then we just discussed about polymorphism, right? And then we also talked about constructor, which is inbuilt, right? Argument, you can say, inbuilt method like this. This is called as initialization function or initialization method, right? And we just discussed about encapsulations, which is also known as abstraction. So these are very important, I should say, characteristics for any object-oriented programming language. All right. Now, Python is also having multi-thread capability, right? Multi-threading capability. So what does this multi-threading capability means? That is something that we need to understand. Now, just to make sure that you understand, right? Understand the difference. Multi-threading is not parallel processing. Parallel processing is different. Multi-threading is different. Parallel processing can be achieved if you have multiple processors. If you have multiple processors in your hardware, in your laptop, then we can do this. Whereas multi-threading is still using sequential execution only, does not do parallel processing, right? Multi-threading can also be known as context switching. So what does this context switching mean? What is multi-threading? How is it different from parallel processing? How Python actually allows us to deal with or implement this multi-threading is something that we will be discussing probably in the next class. So as part of today's class, we are only having a small object-oriented programming introduction with Python or for Python. Now, I also want to recall before we wind up, I want to recall that there is quiz which is being conducted every day. So do chance, right? Do have a chance to win the quiz competition, right? It's fun learning, right? It is fun competing also. So try participating in the quiz. This is how you will remember things. When you try to answer the questions, you will never forget, right? So try to participate in the quiz. Today's quiz is already posted in the chat window. You can check the chat window. You can visit the LinkedIn page and participate in the quiz. And attendance link is also given for your reference in the chat window. You can almost click that link and mark your attendance. People who have won the previous quiz, right? Quiz winners, we will be contacting you. We are basically contacting and right, giving the prize, the winner's prize. So you don't have to worry. We will be contacting. Okay. All right. So this is with respect to Python features. One of the features that we are speaking about is object-oriented programming language. This object-oriented programming language is more appropriate for proper detailed programmers or specialist programmers. This object-oriented programming capability will allow the programmers to do much more optimized coding. Whereas a functional-oriented approach is like reuse, straight away reuse. I have a function, I'll just reuse that function without much fuss about doing the programming. From organization's perspective, right, I am more interested in looking at the time to market of the product. Right? This is more important aspect for me, time to the market. Right? If I have to develop anything, I need to make sure it is developed at quick time and it is ready to be deployed into the market. Now, if I have to look into this specific aspect, then functional oriented language capabilities, right, are basically helping us to turn around that time, right? It's basically reducing the turnaround time drastically. And you don't have to, right, also really worry about a lot of coding. That is another advantage for your functional oriented program. And as we have seen, Python is basically capable of all these things. It also helps, Python also has shell scripting capability and low-level programming as well, modular programming as well. People who are coming from electronics background, right? Large-scale integration, circuit development and all that. When you probably have learned in your academics, right, previous, I mean, already, right, electronic engineers who are working in the industries and all that, you people might have learned coding these devices, right, sensors and all that, using C programming language, right, or low-level modular level programming language. But now, if you look into today's generation, they are basically writing the codes to, right, design something on your integrated circuits or sensors. They use Python programming to do that, right? And Python programming is high-level programming language, which is much, much, much easier than C or any other low-level programming language. This is also one of the areas where Python is catching up, and it has already come. Right? Popularity. They're looking at the popularity of Python programming language like this. All right. So these are some of the things that I basically wanted to explain. All right. All right, that's it, friends. I think we have basically looked into the OOPS concepts. We will connect tomorrow, and then we will look at multi-threading capability to start with, and then we will also see how right, other features can be handled in Python programming. All right, we'll wind up for the day. Please mark your attendance and participate in the quiz. See you guys tomorrow. See you all tomorrow. Thank you and have a very good evening. Thank you all.